And welcome back to another episode of the Game Engine series. So last episode, pretty fun stuff. We upgraded to Zig 0.16, but now let's get back into the engine. Let's keep things moving. And today we're going to do shader uniforms. So that does come with a little caveat that as the series goes on, I want to continually improve our code, improve the structure, make sure things are tested well, we're handling errors, all of that. So we're going to do a little bit of work just improving the code at the start of the episode. That's going to be our vertex buffer, index buffer, and vertex array. But once that's improved, we'll move over to the shader struct and implement our uniform function, or set uniform function. But I'm not just going to make it a basic like set uniform 2D, set uniform float. I'm going to show you guys how to write a single set uniform function that leverages Comptime to determine the various types that you can pass in any type, and then we'll find the correct OpenGL function given the type, and that'll all happen at Comptime. So I think that's pretty cool. And then I'll also show an optimization where we can fetch all the uniform locations at the start when we create our shader, and then we can easily just fetch that from an internal map when we go to set any uniform values. So in our main loop, we're not continually looking up the shader locations, but instead it's all cached, so we avoid a lot of OpenGL GPU calls. We get the shader location, and then we can just upload to the shader uniform at that location. With that said, because I want this set uniform function to be as good as possible, we're also going to add on our math library that we're going to use. It's CLM. I'm not sure if we're going to use that for the whole series. I might find a different one or write my own. Haven't quite decided. It's a pretty basic one, so should be easy to replace, but we'll use ZLM so we can start passing in like 2D, 3D vectors around some matrices. And then it makes the shader code a little bit easier right now if we know the kind of structure we're going to work with vectors. Yeah, that's all I have. So let's just jump into the code. Okay, we're in the code. So as promised, some things we're doing today is updating some vertex buffer, index buffer, vertex array code, adding math library, which we're going to do first now, change my mind, and then finally getting to uniforms. So let's start by adding our math library. So the first thing we're going to do as always is actually fetch it. So it's github.com/ziglibs/zlm.get. So we will fetch that and make sure you do it in your runtime folder. And now let's actually add it. So just like any dependency, let's actually just copy glfw. In this case, we'll replace glfw with CLM. And then I guess in this case, we'll just do CLM. So we have that dependency. So it'll be a little bit different down here. What you do, since this is ZLM is purely Zig, we don't have to worry about artifacts or anything like that. That's all for C code. So we can just do ZLM, add the import, ZLM dep, nice, and then same with lib, or libcheck dot add import, CLM, CLM.module, CLM, and then the last one will be lib unitest.rootmodule.add import will be ZLM, ZLM.module, CLM. So now let's go over and actually create a math file in our core. So math.zig, we'll import just math from ZLM. So we're going to keep things very simple. Like I said, I'm not 100% confident I'm going to use CLM yet, but let's see. Doesn't seem to want to be loading. So let's do a Zig build check. There you go. See, there were some errors. I missed calling it dep in a couple places. So again, if you want IntelliSense, make sure you always run your check. Well, let's keep running them for now. But we'll do vec3 equals math.vec3. And same with vec2. And then there we go. And then we also want a mat4. So now that we have that, let's head over to root. And now we can import all that. So we can go const math equals import core/math.zig. And then we're essentially just writing the same thing. And this just makes it easy to work with when we're actually importing, which we'll do right away. So now if we go back to our game scene, there we go. So now we have vec2. And what's really nice about this is now we can replace our offset to just be a vec2. So we get x and y, head down right here. So offset equals .x equals 0. So this is just saying the defaults. And now we will come down. And in this case, replace underscore with dot. So now that we have that, it should be everything. So if we just try and run that. Oh, there was one place. Let's just do that dot x right here. The actual usage, of course. So now we go try and run that again. And now we can see it's the exact same thing. So I will try and fix up the IntelliSense. Oh, now it seems to be working. There we go. Okay. It just, I guess, took ZLM a while to index all that and find it, but yeah, it's working now. So that's perfect. Okay. So now people may find this boring, but I think it's pretty important to be doing this, like keeping code as well maintained as possible. So we're going to do nicer errors. Buffer error. And you can skip this if you want. I don't recommend it, but if you try and get to more interesting stuff, there will be timestamps. Yeah. So now vertex buffer will return buffer error or a vertex buffer. And now even after we generate, we can do a nice check. .id equals 0. That means it failed. So we can do a buffer error, buffer creation failed. And now we can also do just a GL check. So const error equals GL get error. If error does not equal GL.gl no error, that means we found an error. We want to delete buffers, vbo.id, and then return buffer error.opengl error. So very simple, but yeah, let's do the same thing. And actually, yeah, very simple. So let's just do the same thing for the index buffer. So let's just go back up here, paste it, replace it with EBO. An exact same thing here. Again, replacing the V with E. So that's all I want to do there. But now we have to actually move over to vertex array, which is a little bit extra stuff here. But just as we did, we will create array type. So vertex array creation failed. Vertex buffer creation failed. Index buffer creation failed, and open GL error. So again, as always, we will put the actual error type there so we know what we're returning. Then similar to what we just did, if foo equals 0, return vertex array error dot vertex array creation failed. So now there's going to be a bit more. So we'll error defer gl delete vertex array, since there could be multiple different cases where we error. So if an error happens, it will automatically clean things up, which is a very nice feature. So now we do want to make things a little bit better. So we'll bind the vertex array, but then do buffer, vertex buffer init with the vertices, but we'll catch that error and log it as always. Failed to create vertex buffer. So we'll log that error and then return vertex array error dot vertex buffer creation failed. And we might not have a CD imported. Let's go ahead and do that. And now, if we look, VBO will be right there. We'll do the essentially same thing with the VBO, but first we want to air defer GL delete buffers VBO.id. So now replace VBO with EBO. Oh. EBO. Let's change this. Come on. There we go. Nope. Come on. Index buffer. Limit with the indices. Okay. Really wants to index count. Indices. Index buffer. Index buffer. And that's EBO. So that's all right. And then just as we did with buffer, I'm going to take this little code snippet, make sure there's no error. So vertex array error, .opengl error. In this case, we don't need to do that because we already error deferred at the start. Nice. And then I also want to try and get rid of as much GL code as possible. So couple things we can do is, one, we know these are just going to be const pointers. Make it a little bit more efficient. And cool. So yeah, so I want to get rid of draw elements, and I think it's up here, or like these two. So we're essentially just going to write those in here. Again, just trying to get rid of GL inside of editor or sandbox app, whatever you named it. So let's do a couple of things here. Const vertex array void. So we'll bind that, and then we'll actually just go over and take these, grab those, run it, or paste it, I mean. What's next? Is in there, and then self.unbind. Nice. And now we'll do draw. Const vertex array void, and then bind it. And then bind after. And I can actually just take this one, and this will be obviously not hard coded in the future. I'm just trying to show a simple abstraction right now for you guys. So let's go use it. So shouldn't need that, should just need self. Let's do an LSP restart. Draw. And this one was self.vow. Not bind, but set layout. So now we have that. If I did it all right, which I didn't in this case. Oh, right. So if you remember, we are now throwing an error, so we can catch that error just as we did here. And return early. Otherwise, let's see log error creating vertex array. Shouldn't actually need a new line there. Get rid of that one. Try that now. There we go. It's working as normal, as expected. Nice. So if we look back here, if we do a scan, we see clearing the color, calls GL, and uniforms. So we're not going to tackle this one today, but we are going to still tackle this one like I promised. So now let's get into the exciting stuff of the episode. So this one's going to need quite a bit, but yeah, and I will be pasting some code just because it's very tedious to do, but I do hope I still get the point across. So we will want a hash map here because we're going to hash the name to the shader location. So what OpenGL does is if we go back to our shaders, there's vertex, we have our uniform. So this U offset is the name. So that will be the key to this map. So the name, like quite literally, U offset will then map to let's just say 1. So this is going to be 1 is the shader location. So I hope that makes sense. That's why we need it. Yeah, so we're going to need a few other things like an allocator, and we also store a couple of things. So allocator will be that, and uniforms will be on that as that map type that we defined. So we come down here to the return dot allocator equals allocator and dot uniforms, and this will be a function, right? Get uniform locations program allocator. So this is all that like optimization to pre-cache the locations, as I said, and we'll write that in a second. But let's just write our deinit pointer to shader void self.uniforms.key iterator and while it.next, get that key and self allocator free the key itself, and then not return self uniforms dnet. So that's just going to free all the memory. And now let's write that get uniform function. So this one's not going to be public because it's just an internal function, but notice here self is a U32 because we don't want the actual struct, but just the kind of reference to it, be a shader error or a map. So we're just going to write a bunch of OpenGL function calls to actually basically get how many shaders or how many uniforms are on the shader, and then iterate that many times, finding every uniform, get the name and the location. And then we're going to fill the map with that information. So I did count gl get program IV self gl active uniforms and count. So this may seem like premature optimization because we're not really running any performance issues, but I still think this is very valuable to just kind of get that optimization mindset from the start. And I think it's showing a cool thing. Like I think most people would just write the set uniform function and call it a day, but I want to show how to go a little bit above and beyond. So we're just initting our map right now. And we know the size, so we can actually pre-allocate all the memory we need, because we know we need, in the first case, it's only 1 uniform, but it could be more. So that's just another optimization. So we'll need a name buff. You may need to increase the size if you have long names for uniform names, but this is okay for now. Uniform count. And now we're just getting basically the info of every single uniform. And this is more C style of initializing a bunch of variables and then passing them as references into an OpenGL function, which isn't great. I'd rather the function just return this data. It's like a struct, but I am using raw OpenGL functions, so that's what I get. So self, let me actually try and do this a little bit nicer. Self, cool, at int cast I namebuff.length, and then again, see we're just passing all those references of all the things we created at namebuff. So that's going to get set all that information for the ith uniform. And now we need the location. So we already have the name from that gl get uniform location. And if you remember in game scene, get uniform location, that is this exact same function. So we're going to call it with self and pointer cast the name buff, which is what we just filled. And const name slice, because we'll have to own it for a second. Name buff of 0, int cast, and then owned name, cater dupe, because we're going to have to store this long term. So we have to allocate our own memory, and that's why we free it. Put assume capacity. own name and location. And there we go. So then actually at the end, we have to return the map. But that should be that function. And now we're going to write our kind of crazy function of setting uniform. I'm just going to write this, a little bit of it, and then I'm going to paste the rest in and explain it. I just think it's easier that way. It's kind of complex when it comes to comp time, so I want to be able to explain it a little bit better. But let's just start by writing the definition. One shader. Great. And again, like I said, any type is able to be passed in, but at compile time, we will determine if we're allowed to set a uniform with that type. So let's get the location from the map that we just got. Get name, or else to log error. This is an error, so not find uniform with name. That means you passed something wrong. And then return. Yes, now we have our location. And one thing to always remember to do is find the shader before you actually set it. T comptime at type of value const. There we go. Then we can do a switch, comptime switch, type info of that type. So again, like I said, lots of comptime, but we're basically just finding out what type it is. So if it's a float or a comptime float, we know we can call GL uniform 1F location F32 value. And I do encourage everyone to try and expand on this. Like I'm going to show a bunch of different types, but if there's more that you know from OpenGL, add to this and contribute if you want the same codes in master or contribute to the branch. Really do whatever. I would appreciate it if you have more ideas with this. But yeah, so here's comptime int to value. So now we can do normal int. So if, and I'm doing everything at comptime, i.signless equals dot signed, then we should do a GL uniform 1I as i32 value. Else we do a GL uniform 1F location as v32 value. So you might notice we haven't used T yet because now we get in the, I'd say, really nitty gritty. So I'm going to paste this one in and then go over and explain it. Okay, so definitely not formatting. Maybe one too many. There we go. Okay, I'm going to zoom out a little bit just so we can actually see everything. But what happens now? So we remember how we had our types was like float, int. So now what if someone passes a struct? So in most of our cases, struct is going to be a vector or a matrix. So how do we determine what? So if it has x and y and not z, we know it's just a vector 2. So we do 2f. If it has x, y, z, and not w, we know it's a vec3. Otherwise, if it has all 4, it's a vec4. But now if, again, this is very specific to the ZLM package. This is how it's internally structured with the vectors and matrices. So if you're using a different package or you're using something yourself, you'll have to change these values to whatever internally you're using. Let's see if I can actually show that example. So we're looking at x and y, right? So if we go, let's just go over to math. We look at vec2, we see it has x and y, right? But if we go into a mat, it has fields. So all the mats have this fields. So what does that mean for us? If it has fields, we know we're looking at a matrix. So now we look at the types of fields. Is it 3 by 3? Then we do a matrix 3. If it's a 4 by 4, we do a matrix 4. Those are the only ones we're supporting. We could also add potentially a 2D matrix here. And you see we give very specific errors. And then let's see if it's unsupported matrix, struct, or uniform type. We give all that. So I hope that makes sense. And again, you can just add to this, really do whatever you need to. I think it's very interesting. It's a lot of fun. Yeah, now let's just finish off this episode by using this function. So how do we use it? Well, we no longer need to get the location because that's all pre-computed. And now it should just be a self shader. We might need to do an LSP restart first. Dot set uniform. I think it was called U offset. And we're just going to pass self.offset. So notice how we don't have to pass individual values now. We just have a very clean, we set the name to its value. So again, if I didn't do anything wrong, which always happens, right, we need our allocator. So if we come back down here, there's an allocator passed in. So we have an allocator. So we'll just pass the allocator right there. And try and run this again. And there we go. It's working the exact same. So exact same code. Oh, there was one memory leak. Probably because now inside of on cleanup, we should be calling self.shader.dinit. Right. So now if we rerun that, and that's again what I love about Zig. If this was C, that wouldn't have been caught. But because we're running debug mode in Zig, it gets caught. Obviously, if it was Rust, probably would have been caught at compile time, but it's still very iterative in Zig. So we see no more memory leak. So yeah, that's all the code for today. And that's it for the episode. I hope you guys enjoyed. I hope you found value. This was a pretty complex Comptime function that we wrote. It's cool though. Like I think it's really cool to show how to leverage Comptime. It's unique to Zig. And I think what I did is pretty unique. I haven't really seen it in other places where normally you write like set uniform or set shader uniform to F or 1F or things like that, where it's just one function per type. But this, it's generic. We can just pass in any type. And at Comptime, we'll throw an error if you try and set a uniform of a value we don't support. If we can't find that OpenGL function, throw a compile time error, and we don't have to worry about that at runtime at all. So I think that's pretty cool. You're setting unique values. And yeah, so as always, come say hi, chat in Discord. That link's down in the description. If you like, comment, subscribe, all those things really help the channel. But until next time, just hope you have a great day.